Hi guys, so today is going to be a quick video. I just want to make sure that before your final or anything, you guys are able to do problems regarding matrices and linear systems more efficiently. Because what I've noticed is that we're able to do these, and sometimes it might take longer than it should because we're still practicing these. But the problem is we don't know if we made a mistake. And it's easy to say that, hey, you should just check to see if the reduced row echelon form is the exact same and then see if your work is right. But then if you check your calculator and then you did all this work and everything and it doesn't match up, you have to identify where you made the mistake, and that can be very tedious. So let's make sure we have a systematic way of always knowing if our process is correct or not. So what I'm going to do is I'm going to make a random matrix. Let's call it A. And then let's say I have the matrix A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say I take this matrix right here. Okay? And I want to make sure that when I reduce it, as I continue reducing it to solve this matrix, that each step is correct. So let's say that on this matrix, I decide to do the first step, which in this case, we like the one right here. That's the leading entry. We like this a lot. But I need to get rid of this guy because the leading entry has to be over here. So if I want to delete that 5, what I'm going to be doing is I'm going to be multiplying row 1 by -5 of row 1. And then I'm going to be adding that with row 2. And I'm going to send that to row 2. Right? In doing so, let's say my matrix A turns into, the first row stays the same, 1, 2, 3, 4. But the second row, you do some calculation and whatnot. Maybe you wrote it on the side so you're able to see it. I recommend you do that. But let's just suppose I did some work and try to do it in my head. Let's say I make a mistake, or if I don't make a mistake. So -5 times 2, that's -10, plus that's -4. -5 times 3, that's -15. So that is -8. -5 times 4, that's -20. -20 plus 8, that's -12. 9, 10, 11, and 12. The moment you transform your original matrix with one single Gauss elimination step, you should stop. Right here. Stop right here. And then what you're going to be doing is you're going to be using your TI-84 calculator. So let's pull that out and let's see if I can do this efficiently. Let's move this to the side. And let's move this right here. This is your TI-84, 83 calculator, as long as it's less than TI-89, right? So what I'm going to be doing is I'm going to click on second. And then I'm going to go to matrix. And I'm going to go to edit. And then I'm going to edit A. And I'm going to call this 1, enter. Oops, this is not a 1, I'm sorry. This is a 3 by 4. Enter your matrix in 1, 2, 3, 4, 5, 6, 7. Apparently there's a delay on this calculator, surprisingly. I guess it's because I'm using an emulator. 9, 10, 11, 12. So before you even do all this math, go ahead and I'm going to click second mode, get out of the screen, go back to the matrix. And, oops, this is not the right button. Second matrix. I'm going to go under math. And I'm going to go to reduce row echelon form. Just all the way down. I believe it's number. Is it number? It's not even a number, it's a letter. Boom. I'm going to click that. Then I'm going to click second matrix. And I'm going to click on A. Boom. Now I'm going to click enter. If I do this, I know my final matrix should be these values. All right, so let's go ahead and write this on the side somewhere, just so we're record keeping correctly. So I know that my final answer should be, and this is to avoid all the messy work that might trip you up. So I'm going to write it. This is what my solution should be. And I do require you to show work, but that doesn't mean you have to get the work incorrect, of course. So, boom. Now, because I transformed my matrix, I'm going to go back to second math. Or not second math, I'm sorry, second matrix. I keep saying math, I don't know why. And then I'm going to go to edit my matrix A. When I did this first step right here, and multiplying -5 row 1 plus row 2 and setting it to R2, all I'm going to do is go to edit and edit my matrix, and then I'm going to edit the row I changed, and that was the second row. I'm going to turn 5 instead of to 0, -4, -8, and -12. Alright? Those are the only changes I'm going to make with my matrix. And I'm going to quit out here, and I'm going to click on second matrix. And what I'm going to do is I'm going to go all the way down to letter B. Is there a fast way to click letter B? I do not know. I'm just going to go straight down. There might be a quicker way to go to B. A, B right here. Reduce row echelon, or yeah, reduce row echelon form. Now I'm going to put that matrix A again. And it better have the exact same result as this guy. I changed my matrix A. I changed the second row after I did some work. So if I did my math correctly, I should still get this exact same matrix. If I do not, that means my math algebra was wrong on the first step. Enter. So this is actually the exact same matrix. That means I did my algebra correct. Yes, this might be tedious, but it'll save you more time than having the final matrix incorrect and not matching it with your graphing calculator and trying to locate your mistake. Locating your mistake and then fixing everything from scratch can take you more time if you're not efficient. So I'd recommend in each step of the matrix, as you're simplifying it, calculate each matrix A as you edit it out. So if I make the first change, edit your new matrix and calculate the reduced row echelon form. It should be the exact same. On the fifth step, do it again. Calculate the reduced row echelon form. Is it the exact same? If it's the same, then you're good to go. Now, it's very important you do not click second and answer. I found out that the problem, if you click second answer, you might think that you can use this to calculate your matrix quicker. However, this is not what answer does. It does not do reduce row echelon of the current A. It gives you your exact same old answer. It doesn't matter if you change A. So do not use this to keep typing in reduce row echelon of A. Otherwise, your answer will always look the exact same. You want to make sure you're verifying if your mistake is correct. So let's do one last example of this. Let's say I did a transformation here, and this is what the final reduced row echelon form should look like. So I have a little reference in case I have to delete my calculator, so I know what the right answer should look like, or the final matrix. So let's say I did, and I'm going to do some math wrong now. Let's say after the second step I did, let's get the third row, or let's do the second row, and instead I'm going to do -1/4 of row 2. And this is going to turn to 1, 2, 3, 4. And let's suppose this is 0, 1. And let's say I forgot a sign, all right? Let's say instead I got this -2 and this is 3. So I messed up one of the signs. Now, when you're doing your test, you might not realize you made a mistake. So this is a very good scenario that could happen. Now, I still have this result, so go into second matrix. You're going to go all the way to edit, get that matrix A, and I'm going to change that second row now. Instead of 4, I'm going to change that to 1. I'm going to change this to -2, 3. Did I change it to 3? I think I changed it to 3. Let's see, just real quick. Yep, I changed it to 3. Now I'm going to quit out. I changed the entire second row to what I think is the correct answers. Now, this isn't the correct answer, but you'll see it. So now I'm going to click second matrix. I keep going there. I don't know why. So I apologize. Hopefully that doesn't confuse you. I'm going to go all the way. Start from down. Can I go down? Yeah, down is faster. Or you can do a row swap. These are also good options, but I haven't shown you how to use it. I'm just going to show you how to manually check this every single time. And this is a very easy way to do it. So I'm going to go to second matrix and click on A again. And I better get the same matrix. The matrix changed, if you notice that. 1, 0. It says 0 even though it's -1. So that means in this step right here, this is where I made a mistake. You can continuously do this for each step. Start with the beginning, and as long as you do this for every single step, you will not make a mistake when solving for matrix. So hopefully that helps you out for the final exam review, or the final exam as well. And I know that this is already, you guys have already started working on your chapter 10 test for some, so I apologize, but I'm hoping that this will alleviate some issues for the upcoming final at the very least. I'll leave it at that. You guys have a good day, take care, and good luck on the final. I wish you guys luck.